Now that we have a pretty good understanding of MongoDB documents, let's begin to explore some basic CRUD operation concepts. In case you're not familiar with the term, CRUD is an acronym for Create, Read, Update, and Delete. These are the basic operations for working with data in MongoDB, or in any other database management system for that matter. To get started with some simple CRUD operations, it's easiest to use the Mongo shell that ships with MongoDB. You should now have a working installation of MongoDB. Let's start up the MongoDB server, and then we can launch the Mongo shell and connect. If you don't already have the server running, you'll want to launch it by typing MongoD at the command line. So here, I'm going to do that in the terminal utility on my Mac. Next, I'll launch the Mongo shell by typing Mongo in another terminal window. In the Mongo shell, I'm going to type help to see a list of commands available. Note that there are commands for show DBs and show collections. In MongoDB, documents are stored in collections. Collections are organized into databases. Let's see what databases are present in the instance of MongoDB I just started up. There are two databases, one called local and another one called test. The Mongo shell is a fully functional MongoDB client application. All CRUD operations are supported. So to insert a document into a collection, we first need to know how to specify that collection in a command. In MongoDB, a collection and the database that contains it form a namespace. So if we wanted to create a database called video that contained collections for, say, movies, television, and actors, the namespace video.movies would specify the movies collection in the video database. When doing CRUD operations in the Mongo shell, we always work with a global variable called db. This variable holds a reference to the database we are currently using. To use a particular database, I can simply type use and the name of whatever database I'd like to use, even if it doesn't already exist. If I use a database that doesn't already exist, MongoDB will create the database for me in a lazy fashion when I insert the first document into the first collection in that database. Now, let's create a single movie document. To do that, we'll need to use one of a few different commands supported by the MongoDB query language. We'll discuss the MongoDB query language in detail in a later chapter. Here, we'll just briefly introduce the insert1 command. Insert1 was added to the Mongo shell in MongoDB 3.2, so let's finally create a document. We can do so with the following command. And then we simply need to specify a document to insert. Since neither the video database nor the movies collection existed prior to us executing this command, MongoDB will create both and insert the document. The return value, also a document by the way, indicates two things. One, that the write was acknowledged, meaning it succeeded, and what unique identifier was assigned to the document. In MongoDB, all documents must have an _ID field. If no _ID field is specified when a document is inserted, MongoDB will add the _ID field. Note that we did not specify an _ID field here. This is an additional value type supported by bson. MongoDB assigns a unique object ID as the value of _ID. Object ID is an additional value type supported by bson. Each document within the same collection must have a unique _ID value. The inserted ID field of the return document for insert1 tells us what object ID was assigned as the value of the _ID field for the document we inserted. In just a moment, we'll look at reading documents from a collection. But before we do, let's insert a couple of additional documents. Let's insert Mad Max 2: The Road Warrior, and we'll also insert Raiders of the Lost Ark. Raiders was actually the first movie I ever saw in a theater. Okay, now let's read these documents we've just created. The command we want to use here is find. Though find takes a number of optional parameters, we often use it to simply explore a collection to see what it contains in the MongoDB shell without passing any parameters. In the case of the movies collection, we can do that with this command. We can get more readable output if we chain the pretty command with find, as I did here. Note here that the ID field values for each document match the value of the inserted ID field provided in the return document for each insert operation we performed. So let's take a look at JAWS 568A1. You'll find a similar match for this object ID and this object ID for each of the other movies that we inserted. The find command we specified here returned all documents in the movies collection. The real power of find is in the rich language we have for specifying selection criteria. In a later chapter, we'll go into detail on the find command, query operators, and other parameters. For now, the takeaway I want you to have is that at the heart of the query language for MongoDB is a query by example strategy. As the first parameter to find, we can pass a document that illustrates the shape of documents we want to match with our query. Now, our initial find query is the same as if we had issued find, but passing this empty document as the first parameter to find. Based on the document passed as the first parameter, find will match all documents that match all of the constraints we specify. If we don't specify any constraints on what should match, all documents will match. If instead we wanted to query by title, we can do the following. To query by year, we can do this. Note that in each case, only documents matching the constraints we specified are returned, both for a query by title and a query by year. One last thing I want to mention before we move on is that the return value of find is not simply an array of documents. It is instead a cursor object. You can see this if we assign the return value of find to a variable in the shell. The shell is a fully functional JavaScript interpreter, so we can do this just as we would in a JavaScript program. We can then use the hasNext and next methods of this cursor object to iterate through the return documents as follows. hasNext returns true, meaning there is a document yet to be visited via this cursor. C.next will grab that document. We know there are 3 documents in this collection, so we expect to be able to call next 3 times. And there's Raiders of the Lost Ark. Now, if I call c.hasNext, we get a return value of false, meaning we've exhausted the cursor. Now, it's important to understand cursors as you use the shell and as you implement applications that use find via one of the MongoDB drivers. You'll have a lot of opportunity to use cursors as we move through this course, and we'll cover much more in the MongoDB query language later. But with what we've covered in this lesson, you should be well prepared to insert any type of document in a collection and perform a few types of queries. If you're anxious to do more, I'd encourage you to experiment with what you know of the MongoDB query language so far, and maybe even review the MongoDB documentation for some hints on other aspects of the query language.